Hi everyone, my name is Torben Jensen and welcome to my course Mapping Real-World Classes in EF Core 6. I'm a freelance software developer with several years of experience working with both Entity Framework and Entity Framework Core. In this course we'll look at how we can map our real-world model to a database using Entity Framework Core. Using object relation mappers such as EF Core is an ever more popular way of building data access logic, and when used correctly they provide a highly productive way of interfacing with data storage, without sacrificing performance. The techniques for mapping our data model that we will cover in this course are relevant to anyone who wants to take advantage of the powerful mapping features EF Core provides us with, and move beyond simply letting EF Core take all the decisions for us. Some of the major topics that we'll cover include changing how EF Core infers our model, mapping special scenarios such as owned entity types and value conversions, mapping database objects such as user-defined functions and stored procedures, mapping many-to-many relationships, mapping inheritance. By the end of this course you'll know how to map your real-world classes to the database in the way most suitable to your needs. Before beginning the course you should be familiar with the basics of working with EF Core. I hope you'll join me on this journey to learn how to map your real-world classes to the database in the best and most performant way with the Mapping Real-World Classes in EF Core 6 course at Pluralsight. Hi, and welcome to the Mapping Real-World Classes in EF Core 6 course. My name is Torben Jensen, and in this course we'll look at how to map real-world classes to the database using Entity Framework Core 6. Using object relation mappers such as EF Core is an ever more popular way of building data access logic, and when used correctly they provide a highly productive way of interfacing with data storage, without sacrificing too much in terms of performance. In this course we'll look at how we can go beyond how EF Core defaults to inferring our database and gain a much larger degree of control over the database model that is created. Before we get started, we'll take a look at a few practical items and also some concepts which are relevant to the course. For those of you who'd like to try your hand at running some of the code in this course, these are the tools that were used while recording. First off, and most central to the course, I used the latest version of EF Core. This version of EF Core will not run on any version other than the latest version of .NET, which is also the version that is used throughout this course. The integrated development environment I'll use to run the code is the latest version of Visual Studio. Note that I'm using the free Community Edition, which will allow you to run all the code shown in this course. Also note that earlier versions of Visual Studio will not let me run the latest version of EF Core, so if you haven't already, you'll need to install the latest version. And all the code is written using the latest version of C# and also the latest version of the C# compiler. For the data storage parts of this course, I use the latest version of SQL Server, and whenever showing things that are specific to the database implementation, I'll do so in the latest version of SQL Server Management Studio. This course does not apply to earlier versions of EF Core. While most of the lessons we'll learn here are also relevant for earlier versions, and many of the features of EF Core that we'll see in this course existed already in earlier versions, this course utilizes the latest improvements in the EF Core framework, so there's no guarantee that everything will work. The first thing that I'd like to introduce you to is CraftRock. For the duration of this course they'll be our employer, so let's take a look at what it is that they do. Well, CraftRock is an online retail shop specializing in equipment for outdoor sports. Throughout this course we'll be working with their customer database. The database structure will serve as a means of explaining the topics that we'll be exploring, so it will be kept as simple and as concise as possible. To facilitate the desired functionality of their lightweight CRM system, the CraftRock development team has created a backend that runs on the latest version of EF Core on top of a SQL Server database. In the upcoming demos we'll look at how they've implemented this, and whenever relevant we'll discuss how their design can be improved. If you would like to run the demos yourself, you'll find the code and other necessary files for each module's demos in the course assets folder. The coding for the demos will be kept as simple as possible. The aim is to support the understanding of EF Core and not necessarily to provide fully fledged implementations. And then, as a last technical thing, I'd like to mention that except for those cases where we are explicitly doing something else, we'll be using EF Core's Fluent API to configure how our domain classes are inferred on the database. And while I said that the coding will be kept as simple as possible, it will still be helpful for you if you know your way around the basics of EF Core. And if that's not the case, I suggest you take a look at Julie Lerman's course on Entity Framework Core Fundamentals here on Pluralsight. And with that said, let's dig in. I look forward to getting started, and I hope that you'll enjoy the course. Let's kick things off with a demo where we acquaint ourselves with the ins and the outs of the data model that the Carved Rock development team has created for us, and that we'll be using throughout the course. Right now the data model is rather simple, but throughout the course we shall build on the complexity as it is needed. We're now inside Visual Studio. If we take a look here in the Solution Explorer, we can see the classes that currently make up our data model. This is the model that we will be working with and expanding on throughout the course. As we can see, we have a customer class, an item class, and an order class. And then we also have a class called Carved Rock Context. This is the database context instance that we'll use throughout the course to control how EF Core sets up our database. Let's start by taking a look at the customer class. As we can see, it's very straightforward. It simply consists of an ID, a first and a last name, and a username. And then it has a collection of orders which represents the active orders that this customer has with Carved Rock. If we now take a look at the order class, we can see that it also contains an ID property, and in addition to this, it has a name property that customers can use to name their orders if they choose to persist them in order to be able to continue adding to them later on. It also contains an instance of the customer class along with a customer ID. The fact that we had a collection of orders in the customer class and a single instance of a customer in the order class means that we have a one-to-many relationship between an order and a customer. In our case, this means that a customer instance can have several orders attached to it, but an order always belongs to a specific customer. In addition to the customer relationship, we can see that an order also contains a list of items which represents the various goods a customer is purchasing from Carved Rock in connection with a specific order. If we look at the item class, we see that this also has an ID property, and in addition to this, a description, a price, and a weight property. And if we take a closer look at the price and weight properties, we can see that they are defined as a decimal and a float property respectively. The reason for choosing the decimal property for the price is that this is the recommended data type for representing monetary values, since it requires an exact representation of the value it stores. This precision is not as important for Carved Rock in relation to the weight, so for this property they have decided to go with the approximated value that a float contains. Notice that in terms of the Carved Rock data model, an item is created so that it represents a type of item rather than a specific instance of an item. So imagine that Carved Rock sells tennis rackets. In our setup, the customer's order will contain an instance of the item class with a description saying tennis racket. This will simply mean that once the order is processed, any tennis racket from Carved Rock's stock can be used to fulfill the order. This will have some consequences that we'll address later on. The item class also contains a collection of orders, which together with the collection of items on the order class creates a many-to-many relationship between an order and an item. In our case, this means that an order can contain many different items and that an item can be contained in many different orders. In an upcoming module, we'll further explore many-to-many relationships and also address the inherent flaw in this setup, which means that a customer can currently only purchase one instance of each individual type of item in a single order. This is not a restriction that C# creates for us, but is rather a result of the fact that we've chosen to populate our orders with instances of a class that represents a type of item rather than, as we just mentioned, a specific instance of that type. Our C# collection could easily contain several instances of the same type, but in the database we'll be forced to create a mapping between a specific order and an item based on the IDs of these instances. Since this mapping must be unique, a specific order can only point to an item once. We could of course solve that by making sure that each item represented a specific item in Carved Rock stock, possibly identified by serial number and a stock location, but this would be a somewhat inflexible solution. As mentioned, we shall look at this in an upcoming module where we deal with many-to-many relationships in more detail. And lastly, we have the Carved Rock Context class, which inherits from the EF Core DB Context class. We use this class to communicate with the database and also to do a lot of setup of how EF Core must infer our data model. Currently we have a very basic layout here, where we have the different collections of items, customers and orders, which represent our corresponding tables in the database. We also have the onConfiguring method, where we set up the access to the database. If for some reason your database needs a connection string that is different from this very basic one, you can simply change it here. This is definitely not the way that we would store a connection string in a production setting, but for our purposes it works just fine. And below here we have the onModel_creating method, where we will be configuring how EFCore infers our data model by using the EFCore Fluent API. We'll return to this method in detail throughout the course, but right now we can just note that the only thing going on here is that the ID properties of the various types that exist in our model are set up to be the primary key of their corresponding tables.